when we talk about the energy efficient building viewpoint, so how do you perceive insulation and components of a building envelope contribute to energy efficiency, saving the energy? Uh, to start with, Mr. Udeet, can we have your views, please?
Right. So the envelope, every part of the envelope is actually receiving heat directly, either through air or through radiation or through convection cycles. So when that heat is incident on the envelope, the components of the envelope, based on the materials that constitute the envelope, will interact with the heat in different ways. And that's where the envelope can actually play a smarter role. Whether it's some elements may be shading elements that don't actually transfer the heat into the internal spaces, or some parts of the envelope might be reflective or low absorptivity. So these material specifications, whether it's absorptance, reflectance, all of these will play a big role on deciding how much of the heat. Of course, heat will come in, but how much of the heat comes in and how much is kept out is where the envelope and the components will play a big role. Insulation plays a big role, especially on places where the openings and the edges of those openings are properly closed with insulating materials. And of course, insulating quality of certain materials like glass, or even in the walls when we have insulation, those are places where we can overall bring down the cross section, the total cross section heat transfer rate, rather than having to address it through all the materials. So we can target specific areas, find critical areas in the envelope, and use insulation to actually bring down the rate of heat transfer.
Thank you very much for those insights. Mr. Jagdeep, can we have your views, please?
It is something that you have to do, and it has to be done. There could be air gaps. We could use blocks which are ash based, which have low thermal conductivity. Even the roof, if you don't have an insulation, put a thermal paint on top. You would be surprised how much heat load you would have reduced. But I would go with insulation a little more. I'm fortunate to have headed the biggest insulation company in the world, Bansal. So my work with insulation has been a little more deep. The temperature from a chilled water from the plant starts at 5.5, 5.6. And when it is reaching the HU coil, it is 8, 8.7. I have had 11 degrees. Now imagine the entire chilled water system is working at a delta of 5 degrees. That means if you have 1,000 tons, the entire 1,000 tons is 7 minus 12, 7 and 12, it is running on 5 degrees. And if the water is increasing by 3 to 4 degrees when it is reaching the HU, how much are you losing on the way? It is shocking. And this Yashobhumi building, the HU was giving 5.6 degrees, and we had 10.5 degrees at the HU. So we had to do a lot of rework, and we had to correct it. Today it is 5.6 and 6.1 at the HU. You can work for about 4.4, 4.5, that's it. Double glass is now no longer a discussion item. It has to be there. You can't allow that heat to come through the delta T that is coming in. It is a no-brainer. So, sir, your question has a very, very big yes. It has to be done. The envelope has to be insulated. It is not a big cost. And the savings are for the next 100 years. No-brainer, sir.
Very nicely said. And that was a good example about the AHU which you have given, as well as the thermal paint. Coming to Mr. Vikram.
This is what I am talking about. There is a demand of the building that has been created by the various factors. Even the lack of insulation could create a different demand from which the system has been designed for. This is what I'm saying, that whatever has been designed and what has been demanded has to be monitored and to see. If the insulation is not there, obviously you are giving the building chance to demand more of the cooling that has been designed for. So if proper insulations are there, the whatever has been designed, the intent will pass on to the building.
Coming to Mr. Jagdeep, while during your presentation you were talking about the chilled and hot water use from the both side and using active and passive cooling, as well as seawater used to be encouraged. That is quite nice to highlight. So, Mr. Jagdeep, how effective are HVAC technologies like heat recovery ventilation or occupancy-based controls to enhance performance of the modern buildings or the so-called current buildings?
Sir, the logic is very simple. The bulk of the energy is consumed by the compressor, and the lift of the compressor is dependent on the evaporating temperature and the condensing temperature of the cycle. The less is the difference, lower is the power consumption, better is the output. So when you use technologies like geothermal, like sea, like sewage, you are exchanging heat with bodies which are lower in temperature. So your condensing temperature is reduced. When you are picking up heat from the building with things like radiant, you have elevated the evaporating temperature. So the difference on an air-cooled chiller between an evaporating temperature and a condensing temperature is about 60 degrees Celsius. But if you use a geothermal and radiant, it is pulled down to about 27, 28. So the power consumption is just 1/3. From 1.4, 1.5 kilowatt per ton, you are talking about 0.4 kilowatt per ton. And it is no rocket science, sir. It is simple logic. And all you have to do is have a little courage to go forward and do designs. There are some basic precautions required in each technology, but it is not rocket science. It has been demonstrated again and again. And we cannot work on the conventional way for very long. You can see out of the 50 hottest cities this summer, 46 were in India. That's not a very good data, sir. And we people who are in this forum are responsible for it. We have to make some amends. I have seen a movie called Ek Hi Aadmi Kafi Hai. I'm sorry, putting a little Hindi. But we are 4 or 5 here. So I think we can do a good job. And we'll have to do it relentlessly. We'll have to keep pushing the industry. We have to keep giving them examples. Yes, it is not expensive. In fact, sustainability is the cheapest way of air conditioning. Secondly, I spoke about passive way of cooling. Sir, your body is like an engine which has 37.8 degrees centigrade as temperature, and like a diesel engine having 90 degrees of temperature. They have a radiator. Our radiator is the skin. And our cooling is on the, if the delta T between our body temperature and ambient temperature is 15 degrees centigrade, you'll be comfortable. If the difference is less, you will start sweating. But if the draft of air is good and the RH is low, your cooling efficiency of your engine improves. And we've gone a step further. We have started using cold floors. So all these put together, and what Udeet said, to make buildings right when you start, these combinations will make spectacular buildings, sir. And you will cut down the energy consumption by 50, 60, 70%. And this is the only way to go forward.
Sir, you were talking about the geothermal systems right now. So having worked across the HVAC and clean energies and geothermal system, where do you see the untapped opportunities for reducing cooling energy consumption? Are there in the existing buildings as well as the retrofit projects which you worked outlining?
Delhi Metro has all their metro stations running on water-cooled chillers.
Correct.
They don't have water. Okay? They are facing a lot of problem. They're buying water at a very expensive cost. I went to them, I told them, you have already made the trenches. You have already done the expensive part of geothermal. Let us put the heat exchangers in the entire tunnel. The Delhi metro system is based on Madrid, the Spanish metro system. The Madrid city has heat exchangers in its entire network for heating and cooling. And we missed the boat. Now they came back to me, let's try now. I said, now you've built everything. I can't break open everything now. So it has to be done at the start, like Udeet said, not later. And we are doing AIMS Srinagar, which is the largest geothermal project of the country. It is going to be 38% more efficient than any other AIIMS. The only net zero university in the country is Nalanda, which is using geothermal. Metro Bhavan, Honda. We just won an award from the Climate Control magazine from Dubai for a project in Uttarakhand, where we cut down the energy by 87%. One day we ran the conventional system, one day we ran the geothermal and radiant system. The electricity bill was noted by people for 24 hours. Same condition in December last year. 87% cut down. So these are not small numbers. And if you ask me how many installations, it will be a very disappointing number. Now, why would people not be excited to do all this? Today, the cost of an air conditioner is almost equivalent to a running cost of the year.
Yes, Mr. Jagdeep, thank you very much for the insights. 87% is very inspiring for the people. They must get encouraged to get. Mr. Udeet, coming to you, you talked about mostly that design, how design plays a very important role for the comfort, as well as facade, as well as you talked about using envelope to bring down cooling load. So considering your approach about the design, the load first, how can architects and building designers use climate analysis, modeling, daylighting, and thermal comfort studies to reduce the load?
When it comes to the types of analysis that can be done, right, there are various different types of analysis that designers or HVAC engineers, people can use through modeling. So the aspects of modeling, begin from, say, what kind of materials you're using and how heat transfers through different materials on the same building envelope. It also goes into shading and shading analysis, which tells you or helps you compare different types of shading strategies implemented on the same building facade, but with different shading strategies. So, so when a designer is making those decisions, so, at the outset, it's usually through orientation, choosing the right angle of the building facing the hottest side, and then working with intershading between different parts of the buildings or multiple buildings shading each other. Then there's ventilation and wind. So how wind interacts with these structures from the outside, within these structures, how courtyard air movement happens, how heat is best removed from the building's skin without allowing that heat to actually, build up on the surface or go into the building. And then as we go into from this early design stage, as we go into design development, we do analyses like a daylight analysis, which helps you understand how much daylight is allowed through the fenestrations, through the windows that have been designed. And based on these, they can be adjusted to reach the ideal optimum size of windows and openings for daylight. But at the same time, it raises, the heat and energy modeling helps us understand how much did that impact the heat ingress. So balancing those two out, because source of heat, source of daylight are both the same, we need to look at how one can ensure that we're getting indirect heat, indirect daylight and sufficiently lighting up the space. Then there's analysis for radiation, where you look at how much radiation is received on specific hours of specific days through the hot months, how much radiation is received in the winter months, and whether that's sufficient as well. So there's a balancing act over there as well, where you try to give sufficient heat in the winter and also protect it from the heat during summer in certain climates. And then there is analysis for CFD internally, where you can look at the air movement, air flows inside the space, and see how each of the particles of air are going to move. Whether it's an HVAC system, whether it's a naturally ventilated system, you can see how the air is moving, identify dead air spaces inside the buildings, and also ensure that these spaces are then addressed by designing the ventilation strategies, locations of your HVAC components, things like that. So then there's also ways to design passive design strategies into the building. So for example, if you want to achieve a stack effect inside the building, you can use these kinds of software-based analysis to actually design the exact pressure that you want to achieve within staircases or within ducts, within specific areas to ensure air moves with zero energy and are able to actually remove heat from the building with just the climatic variation through different seasons. And then there's renewable energy potential, which can be analyzed through these same types of softwares that give you the potential of your terrace or now even your walls or your windows and how much solar energy you can generate from the building envelope, which again offsets the energy cost from the grid. Yeah, so these are all, I mean, there's a long list. There's about 20 to 30 different types of analysis that can be done, but these are a few examples which I'm trying to illustrate so that you can visualize how these can actually inform the design process. And sometimes these actually speed up the cycle of design, where a designer can actually arrive at his final optimized version or take his decisions faster versus trying to look at the aesthetic options that are available. Analysis can quantify these numbers for you. It can help you to decide very quickly that this is the best way forward, and then design around that. So there's actual savings. There's actual cost savings even in the design process if one is able to take faster design decisions and reach the final design faster.
Thank you, Mr. Udeet, for covering so many points. And there's a huge checklist as well as analysis that has to be carried out to save the energy. Coming to Mr. Vikram. So you were talking about the designing and operating efficiency as well as gaps for performance. And a small change can be a corrective one. When you are focusing beyond design intent and efficiency gap, so why doesn't designed HVAC plant fail to deliver its expected performance once the building becomes operational? Any reasons?
So first of all, the reasons, as you talked about the insulation part, if the building is not being done properly, whatever has been designed, so if the execution part something goes missing unintentionally, that start building us for the inefficiency into system because your system has been designed to operate in a certain way. If something during the execution it is misunderstood or it is unintentionally ignored by anybody, any of the stakeholders, it eventually adds up to the inefficiencies because suddenly your building starts demanding something which is not been designed for. So when this design and the operation parts are matched, somebody has to be there from the inception of the design till the end of the design. What I see, that a lot of teams are changing from the design part to the operation part, and there is no proper handover of the intent, what was going during the design. The designer are there till the tenders are awarded. The execution are there till the handing over are there, and the operators doesn't know how the things has been designed initially. So they start putting their logics into it. The building demand is not from the day one, which has been designed. Takes a time to go to that peak level. But the operation team, which is not aware how the system has been designed, they start putting their own logics, which makes these systems inefficient in a way. Because the focus goes on the individual equipment. That every equipment has been commissioned as per the design. But as a system, what I feel the system commissioning is missing because that building load that has been designed, it is not there from the day one. It takes time to build that room. Though I think that gap is there.
Yes, you rightly said that commissioning is missing, and you were also telling in your presentation is stop commissioning equipment, but commission
Yes.
performance. Going forward, Mr. Vikram, so how do building designers balance energy efficiency while maintaining the good air quality without compromising the comfort?
But what I feel that the metrics of benchmarking needs to be changed. Now we need to see the performance of the system has to be defined clearly. That uh, what would a good design at operation would look like? What should be the power consumptions, which we're talking about efficiency? What should be the in designed or intended efficiency from the system which has been designed? The day we start measuring it, so I think that the mindset of the stakeholders at every level will start changing. We are not asking the right questions from the every stakeholder. This is what I believe.
Yeah, thank you very much for those insights. Mr. Jagdeep, so how can thermal performance consideration be integrated into construction practices without increasing the cost or the timelines?
There are guidelines of an power consumption per square meter per year given by standards in 2.5. That's what we should target. And believe you me, sir, we have enough technologies. You have guys like Udeet designing. You have technologies which are available by us installed. What Vikram said, if the right commissioning is done, sir, I'll share with you that the BMS installed, let's say, in 100 buildings in India. Do a audit after 5 years to see how many buildings have those BMS systems running with the data being collected and the monitoring system being run. The number is so poor. It is about 5 to 6% of the buildings are only running. That is what Vikram was talking about the knowledge and capability level difference between the operator, designer, and the implementer.
Correct.
We have to bring them all to the same level, same focus, same thinking. So until and unless we bring all the parties interested to a common platform that this is what the building should be doing, you get a green certificate. You get it's like getting an engineering degree. But until and unless you use your knowledge for something positive or something you can contribute to the society, it has no meaning. So the green buildings should be audited after 2 years, 3 years, 5 years, 10 years, and the numbers will be very strange, sir. And you will have most of the buildings lose their certification. So, to my mind, a good design with all the traditional knowledge capability that India already had. We had very cool buildings before the advent of air conditioning. First, we created a mess. Now we are spending double the energy to handle that mess. So let's go back to our roots. Our roots have a lot of solutions. Use them, local materials, local technologies. What our hundreds of years, what has been used, use them. Bring in the modern technology in a way which is sensible. Don't overdo it, don't underdo it. There is no simple one key for every project. Every project is unique in its application, in its location, in its orientation, number of hours it is operating, and you will have to bring some customized solutions. All that is available. Point is, we need to take a step forward and have the courage to get into the water. पानी ठंडा है, सिर्फ first mug you will feel, but after that life will become very good. We will start like Beijing. Sir had about Beijing is just like Delhi. The temperatures, summer temperatures and winter temperatures, just like Delhi. About 16, 17 years ago, when I used to travel a lot there, the IQ level, the AQI levels were very bad. They were just like Delhi now. They have brought it down to 50, 60. So if China can do it, we can do it better.
Very rightly said, sir. United approach is very necessary for all the stakeholders who are involved for any project. Coming to Mr. Udeet, do you think reducing a building's project cooling or heating load, and as well as using the heat recovery through architectural design, is effective than relying on the HVAC systems?
Absolutely. So I think it's definitely more efficient. Heat recovery by itself, in the name itself, it essentially talks about efficiency and how we are not letting things go to waste. So the recovery aspect is about channeling from one side to the other side, like Mr. Jagdeep mentioned, that you have heating and cooling happening and heating and cooling demands. So both these need to pair up. It's sometimes just about the timing, or sometimes about being able to store and then deliver at different times, or sometimes even using the right technology like Radiant, which can deliver both heating and cooling to your entire building, and it can switch seasonally. So there are so many ways in which this can be addressed. I think so. From a heat recovery specifically point of view, I would say yes, it's definitely more efficient. But I think that there are a lot of different aspects that are actually overlooked altogether. Because very often, I mean, this is my take and my experience also, that why sustainability in a way is taking longer than it should. While India has always been 20 years behind, while there's so many other countries that have been at it right from the beginning, and then while we're 20 years behind, we're still kind of in some ways also slower or more lethargic to actually jump into it and embrace it. Even the codes, we kind of start a little gently saying people need to accept it, and then we'll slowly make it more and more stringent later. There's a lot of pushback from developers, a lot of pushback from the even the HVAC lobby many a time to not allow low energy technologies to come in or passive designs to find solutions, because finally, the fees or the rates are linked directly to TR, and so there's actually incentivization to just subscribe and put in more and more safety and TR to the systems. So some of these things actually, at a maybe policy level or at a fundamental level, if there are newer ways to address this, which I think Mr. Vikram's also in some ways talking about, of going into the heart of the problem and finding newer ways rather than de-risking one's approach and saying, let me just do what the last guy did. Let me just keep following the conventional method. And then that kind of is a big slowdown, a big inertia to the overall change that anyway needs to happen. So the climate's not slowing down for anyone. And so, while all the technology already exists, it's been available to us for the last 10 years. And, only what's getting mandated is what's actually happening. And then there are a few others who are actually leading the charge, leading the movement and saying, no, even though it's not going to make me money, I still make that change. I still, or let me take that, leap of faith and try to be the first one or the first few to change. And whether it's from both, and this is something that's true on both sides, from the design side as well as from the HVAC and system side. Efficiency of the building is one part. The other part is overall finding a newer, accepting and embracing newer ways of doing things. So, I think it's somewhere part of the change is about having a conversation across the silos, not making design a separate element and systems a separate element, but making it all part of one conversation and all aligning towards one solution at the end of the day.
Very well said, Mr. Udeet. The cohesive approach is very much required, as Mr. Jagdeep also mentioned. People have to come together to understand the problem and combine the traditional ways into the modern methods with the technology of AI and other things. Mr. Vikram, do we have any regulation to assess the building energy envelope solutions or the insulations after it is installed or commissioned?
This is, I'm also curiously finding out is there any documentations or guidelines are there. I will add to what Jagdeep ji told about the green buildings. I see the green
Correct.
buildings is certification is awarded for the design
Mhm.
part of it. But fortunately, unfortunately, I have done a lot of hospitals audit, and every
Mhm.
hospital was green building, and they were bleeding energy like anything. And their ESG heads were struggling to get the required savings from their building. So I think there should be some guidelines that should measure post handing over of the system, the operational part. What I feel that everybody is just focusing on the capex. Nobody is talking about the
Correct.
total cost of ownership of the system. The day we
Yes.
start handling it, with the day we start seeing the design as a solution rather than a BOQ of the equipments, I think that mindset will help us to achieve the efficiency. I truly believe whatever Jagdeep and Ajanthan, there are a lot of changes has been done in the designing part. There are a lot of solutions are there. We are already have the installation base to see that solutions giving up the results. But somebody need to take the ownership to think about the solutions, not about the equipments. I always see that the project is sleeping when the capex is the top. If you start talking about the total cost of ownership, I think the solution will be more easy to execute rather than to debate on the piece of paper.
Correct. CapEx has to be replaced with the TCO. So maybe have your last your viewpoints. Could you share, Mr. Jagdeep? What do you have to say about the passive design strategies and or Mr. Udit? So want to have your last comments.
May I start first?
Yes, yes, please.
First of all, we have to move out of the conventional, relaxed design basis that we are in.
Correct.
Every project has to be seen as an individual project with the application around it, the ambient it has, the load profile, the people, There has to be education of the entire cycle, right from the designer to the executor to the maintenance team. Everybody has to be thinking the same. But this was the aim, and this is what has to be executed. This is what has to be implemented. Then you have to use passive technologies. They are the easiest route. And in the entire building, try and put some areas, non-critical areas into passive, critical areas into active. Even into active air conditioning, there are so many technologies that can cut down our energy. So what we have to do now is stop throwing your heat in the air. Start thinking sustainable, because we have a borrowed earth. It is not ours. We have to leave it for our children in the way we got it. And I think time is running out for India, the way we are going, the way we are expanding. I think the government also has to take some, it has to take some stand. It is not easy. I know we are a very large country. We have a lot of people, and to get everybody together is not going to be easy, but it is not impossible. And everybody has to now start talking the same language. This has to become a part of our schooling. This has to become a part of our culture. Right from the young guys' mind in the school, they have to be taught that we have to look at environment as our only hope for future. So once that seed is imbibed, is put in those young minds, they will come out. It will take some time, but I think it is the time to start that revolution.
Yes, very much there.
And this kind of forums that you're doing today have to become a regular feature, and people have to be educated that they cannot keep their eyes closed, because the danger is just standing outside your window. We have to open our eyes.
Yeah, very rightly said. So awareness is very necessary, and that has to be spread. Mr. Udeet, may we have your last comment for the panel discussion now?
Thank you all. This has been a great conversation. And really, for me, the word conversation is my whole point. The best buildings happen when the envelope and the mechanical systems are designed together, not in silos, and we're working towards one common objective. So let me end with an invitation, to all the mechanical and HVAC engineers listening. You're the front line of this, and I genuinely love to hear from all of you to swap ideas and to find ways that we can work together on projects where architecture and building services are trying to pull in the same sustainable direction right from day one. And that collaboration is not just a nicer way to work, but it's the way of the future. It's the only way that things are going to get better. And this is exactly what we believe and do at Green Grid Design. So do reach out and let's build the next generation of comfortable, efficient, and climate ready buildings together. Thank you.